Welcome everybody to the public teaching for gardeners and growers in English. It's Sunday the 22nd of January. As usual, we'll just go run through all the options available for people to gain extra teaching. And it was the agriculture, apply for the private teachings online, which is just €100 for the year, and then obviously the books. I think these are just basic resources that one needs to have, particularly the books, because there's just so much information there. All right, so we start with our fourth growers and gardeners workshop. In today's workshop, what we're going to do is look at a lot of the practical experiments that we've done with the focus of how using the GanS on the seeds and plants affects the environment. So what we'll do first is our fridge trials, where we looked at our micro radish. We also did some trials where we grew some tomatoes through wintertime. The effects of extreme summer heat on our lettuce, and the sort of unintended consequence of some pest control that we found in using the GanSs. So first of all, we'll start off with looking at the whole idea with this experiment was to see if we could, how long the shelf life of the produce would last if it was grown using the plasma. This is a picture of our micro radish that we supply to our customers. It's just the daikon radish, and it's about 7 days worth of growth. And when those first two leaves come out, then we just cut it and punitize it. So that restaurants and people use it as garnish on their meals, and it's a very nutritious to eat on its own as well, packed full of vitamins and minerals. So what we did with our radish to get that, we soaked one batch of our radish seeds in plain water, and then we soaked another batch of the seeds in a CO2 and CH3 plasma water. So this was just the water only, no GanS in it. And we soaked the seeds for 24 hours. Both of them were seeded in plain cocoa fiber after that and left to germinate. Then during the next 7 days, each batch was watered respectively with just the plain water and the other one with the plasma water. Both batches were harvested on the same day and packaged, and what we had previously found the previous couple of years was that we only got around 11, 14, 15 days of shelf life on our radish. Here's a picture of soaking the seeds. So the one on the left was just soaking in water, and the one on the right with the plasma water. So this is how we just left the seeds for 24 hours soaking in the water. We then planted them into the cocoa fiber in those punnets. And just to reiterate, the cocoa fiber is just a holding mechanism medium. There's no nutrition whatsoever in the cocoa fiber which would affect either one. The seeds are covered with cocoa fiber and vermiculite, and then they were watered respectively. So those that were soaked in CO2, we had watered again with some of the GanS water of the CO2 and CH3, and the other seeds we just watered with plain water. Here you can see the pictures of them starting to germinate. The one on the left with the plasma radish, and the one on the right with the plain water radish. So you can see they both, there's no difference between the two at this stage. And again, we've got, once they're germinated, and we just take the cocoa fiber off the top there, and then when they're exposed to the light, they'll start turning green. The water only and the plasma water, the comparison there, also no real changes. And here's just before we started to harvest, the one on the left being plasma and the one on the right being just the water, plain water treatment. What we had noticed, up until this point, they both looked exactly the same, but when we did harvest them, what we did notice was certainly a difference in the root structures between the two of them. The top row there was the root structures of the radish just in the water, and the bottom row is those that have been soaked in the plasma. So you can see that there's a more rigorous root growth. It's whiter compared to the other one. So that was our own the main difference that we had noticed at this point in time, was just the enormous root growth compared to the plain water. So we cut the radish, washed and placed into the containers, and then these two containers were placed in our fridge, and we started the countdown. So that was day 1. On day 9, what I've done is the photo on the left is always day 1, and then I'm comparing it to the current photograph. So that would be day 9. At this stage, no change whatsoever. Is day 14. Now, normally, when we start getting to day 14, previously our radish would start certainly going yellow. You would get a smell from it, and generally you wouldn't be able to eat it by that stage. It has a very short shelf life, but after 14 days, it was still looking very, very strong. One could easily eat that radish with no problems. On day 20, also virtually no change from day 14. Still looking very good, no signs of any yellowing or rotting at all. On day 28, we have the same, still very green, and no change in the state of the radish. Day 41, we had started seeing, you could see some of the radish had sort of a bit of discoloration there, going yellow, but otherwise the rest of it was still looking good. And when you felt the radish, it was still very, very firm, and it hadn't gone soft or soggy at all. There was another photograph that we took on day 47. And then we went to day 78, because then I'd forgotten about them. And when I looked at them, you could see that they had started going yellow, a bit more yellowing on the plants there. At this stage, you probably wouldn't want to eat them, but even though there was no smell coming off the radish and no sign of any rotting of the radish at all, but just that bit of discoloration of the yellowing. Then we went all the way out to day 134, and here you can see that completely gone yellow, bits of green there, but still no rotting happening. There was still no smell coming off the radish whatsoever. There's just a side view of those punnets, so you can see none of it had sunk down to the bottom, because generally that's what happens, is it all sinks to the bottom and turns into a liquid and just rots. But this is still quite firm and sort of spongy, taking up all the space in the container. And then we went all the way out to 180 days, and yes, now we're starting to see some degradation there, and a bit of rotting of the micro radish. But even when we opened it at this stage, there was just no smell of rotting. It was a vegetation smell, and none of the real rotting smell that one would get from the radish. And you can see also at this stage the radish grown in the plasma is almost identical, a little bit better than the one grown in the water. All right, so there's a side view of the radish, and now you can see how it sort of settles to the bottom, and it will just eventually rot and form a nice black puddle in the bottom of the container. At this stage, we thought the experiment was over, and so we gave these to our chickens. Right, so when we look at the observations that we made from this experiment, is that since we started growing the radish, we've been doing it for about 3 years, none of our stuff had lasted beyond 15 days, even in our fridge and in retail shops. We always had a very short shelf life for this product. And during this time, by the time we got to 15 days, the rot would set in, and then you would have a smell that would fill the room because of the sulfur coming off from the radish. Only after the sort of the 41-day mark could we smell a slight odor from the water radish, but not the plasma radish. And they say that odor was more of a vegetation odor. It was not the sort of sulfur smell that one would generally get from the radish. And we saw a bit of yellowing of some of the leaves in both containers. The interesting point here as well is the weight of the radish on day 1 was 47 grams, and even after day 41, it was still 44 grams. So it only lost 3 grams of moisture during that entire period, which is also quite astounding. And both were kept in the fridge at 4 degrees. Now, the big question is, why did the radish grown with the water only last just as long as the radish grown with the plasma water? Because we're a bit stumped at first, because we thought that the plasma radish should have been far better than the radish just planted with the water. So that was a big question that we had to answer. So essentially, because the water-only radish and the plasma water radish had been sitting next to each other from the seeding stage, as you could see, when we soaked the seeds, they were next to each other. When we seeded them, they were next to each other. During the whole growth stage, they were next to each other. And then even in the fridge for the 180 days, they were either sitting next to each other or on top of each other. So the plasma radish, the radish that we soaked in the plasma had been interacting with the water-only radish. So the stronger fields were interacting with the weaker fields, thus causing the water-only radish to last just as long as the plasma radish. So essentially what is happening is, because they are both composed of the same material, they're both radish shoots, the one grown in plasma, being of the stronger fields, was interacting with the weaker one, which was the plain water one, and this was feeding and making sure that the water one stayed just as fresh as the plasma radish. And so you have that interaction from between the two, so the higher strength feeding the lower strength, and the connection is because they are of the same material. And then we had the next question was, why did it last so long in the fridge? 180 days was a very long time for any produce to be sitting in the fridge. And then we have to go back to our CO2 story. as to why, when we use the CO2, why it works. And so we go back to, it's the connection between the amino acid structure of your seed and your plant, which is your carbons, oxygens, hydrogens, and nitrogens. So when you look at your CO2 GanS, it's your carbon and oxygen is the connection between your CO2 and your plants, whether it's the seeds or the plant matter. So essentially, by soaking the seeds in the CO2 water, we have created a maggrav field strength around the seed and the plant. So we've changed the whole environment around the plants. So it's not just a case of feeding the seed and, oh, well, it's going to change the seed. What it's done is it's created a whole new environment around that seed and plant. And when we look at food as to why food decays in our environment, food decays because it is essentially losing its field strength to the environment. So this decay process is exactly the same as when a neutron decays into a proton and electron. The environment is the weaker field and the plant is the higher strength. So what's happening here is your field strength of your plants, especially the freshly grown plants, of a stronger field, and they are giving into the environment which is your weaker fields. So that is why food rots if left open or doesn't last very long in a fridge. And the shelf life of your food always comes back down to how strong or healthy your original plant was when it was grown. So essentially, the CO2 environment is created a whole new field strength around the plant. And we know that the CO2 has a maggrav field strength of 44, and your amino acids of your plants has a field strength of 43. So your CO2 had created an environment that was protecting the plants from your normal outside environment. And this is why it had lasted so much longer than before. So some of the implications is, can we place CO2, zinc, and amino acids, plasma water in our fridges at home to extend the life of the fresh produce we buy from the stores? It's an interesting point there. And can we place the same plasma waters in the store shelves to extend the life of produce in the store? My feeling is that it's best to start right at the source, so grow the food with the CO2, having the full nutrients in the plant, and then you can extend the shelf life of those plants much longer. But this is all sort of open for people to test as well, is to try and place some plasma devices in their fridges and just to see whether their fresh produce lasts longer than before. Any questions on this so far?
Jimmy,
Yeah.
was there any CO2 in your fridge besides the two samples?
No, this is just a separate fridge which we use to put all our produce in there, and there's no other CO2 or anything in the fridge. The other thing is, which probably might have an implication, is that the fridge on the electrical circuit is connected to our maggrav. So that might also play an interesting part into it as well.
Although I have my doubts, because in our fridge, which is connected to the maggrav that's got our normal veggies that I buy from the shop, they don't last any longer in there. So I don't think that has much to do with it.
Oh, I see. Well, that sort of proves that point. Anyway. I have placed some CO2 and plasma water in our fridge and trying it out. keep things a bit fresher.
Yes, and what have you noticed?
Nothing much at this stage, but I guess I should run a test like you have and try that out. I'm just wondering whether they would have any nutritional effect on the food, in fact, in the fridge. That would be interesting if there could be a nutritional analysis of the food. That would be of quite interesting, but it would have to be a laboratory test, I guess.
Yes, I think, our feeling is that to get the best benefit using the plasma is one has to start right at the beginning, from the seed stage, and even if you're starting with the little seedlings, when you water them with CO2, we want them to be immersed in those fields for as long as possible, right from the beginning. In doing so, yes, I think it would be very interesting to compare nutritional values to see whether the plasma does affect the nutritional value on a positive side.
Yeah.
Allowing it more to interact with the environment, yes.
Yes, I am growing tomatoes and cucumbers with occasional watering of plasma water. I'm not sure what percentage of plasma you use in your water. That would be of interest to me.
It's just it's only taking the water off our GanSes. So we're not using any of the GanS in that water. We just tap off some of the water off the top of the GanS, and then we just soak the seeds in that.
I see. And when you water them, that's what I'll probably do. I'm just concerned in one aspect that the seeds would would regress back to a original seed form. I don't know whether they have been tampered with, those radish seeds of yours, but if I get tomato seeds or tomato plants and well, not plants, seeds, and soak them in water, would that regress the seeds, do you think?
It would have an effect, and only, we've never grown these radish out to full size, so we don't know what effects it would have. It's just something we've never done on the long-term growth of it. So, there's a lot of room for experiments to carry on out there and see the results of soaking of your seeds, because it.
What we normally do is we soak for 24 hours because that's our normal method of getting a good germination for our microgreens. So we soak for 24 hours on a little, like a heat pad, so that we get strong germination. Otherwise, we have to rely on the elements, which isn't always a good thing, because then in winter, a lot of the stuff doesn't germinate. So we have to be quite precise doing it for commercial reasons. Yes,
I understand. You mentioned you grow produce through winter, and I'm interested whether the plasma would increase. Like, for instance, it's a little too cold here for tomatoes. I'm just wondering whether that would give them some sort of immunity against the cold.
Yeah, well, further on we'll talk, I think we'll talk now about the next one is about growing in winter and what we did with our tomato plants in winter. So we've done that, yes, and we'll show it now.
Oh, good, thank you.
Okay, any other questions, or we'll carry on? All right. So yeah, growing our tomatoes in winter. So this was, I'll hand you over to Lee and she'll go through it.
Okay, my turn. So, backgrounds for tomatoes. In April 2016, at the end of summer, we normally pull all our tomatoes out of our aquaponics system. And what happens is sometimes little babies will just literally pop from the seeds, and we'll find little babies growing literally in the water by themselves. So normally I would throw them out, but because we had plasma in this system, we decided to test and see what was going to happen. So we found 6 little baby plants at about 30 centimeters long, and we replanted them in to see how they would grow through the winter. So that was April 2016, which is our autumn here in the southern hemisphere, and so these would have to be growing through the winter. In previous years, we've tried to grow tomato plants in winter, even in our greenhouse, which is not a big greenhouse, with no success. They do not die, but they remain very small, and they don't grow at all until the spring starts. So in the aquaponics system, we had also placed bottles of the GanS in the water, and we were also foliar spraying the plants at least once a week with the liquid plasma water. So this was the 31st of July 2016 in the midwinter. Yes, we didn't have a very icy winter this year, and we are coastal, so we don't get a lot of frost. But yes, the grass was brown, and we had slight frosts through time. So if you notice, the stems are very thick, which was highly unusual, and they were growing strong and had good development on the ends, the tips, the growing tips. And this was the 16th of September 2016. As you can see, they're as tall as a man, and we would normally be at this stage either planting seeds or have just taken tiny seedlings out of our greenhouse to put into the system. So we already have huge amounts of growth, and we are, if you have a look here, the stems were as thick as a pencil, and with cocktail tomatoes, they often aren't hugely thick, so these stems were almost like your big beefsteak tomato stems could be. This was on the 11th of October, so they'd already started making beautiful fruit. It wasn't very hot yet, so the fruit was still quite green.
Just wait, it doesn't.
Oh, there we go. Sorry, it didn't come through so fast. So yeah, the 11th of October, the fruits started looking like it was nearly ready. And this was just as everything was warming up. So the comments were, our tomato plants have grown through the winter without any cover or a greenhouse. We were picking fruit in about 2 weeks, that was in October, compared to only in December or January of previous years, because our seedlings always normally go in September, October. Traditional planting and harvesting seasons can be extended, and there's no need for expensive greenhouse infrastructure. We can grow crops in areas and conditions that they would not normally grow in. So now we also have some feedback from January 2017, which is now. So during November, we were picking lovely tomatoes with real flavor. When summer really kicks in here in Australia, we go from normal weather of 25 to 29 degrees Celsius to heat waves of 35 to 40 degrees Celsius. This hit us at the end of November, beginning of December. The changing conditions were too much, and the tomato plants could not cope. They became very weak and unhappy, and what we've done is we changed the environment so that they could grow well during the winter. But when the change in the mangrove fields to extreme heat happened, it was too high for our field created around the plants. Our environment became the weaker field in relation to the new environment of extreme heat. So we can now understand that if we create a stronger mangrove environment around our plants, we can grow food all year round without the need for expensive greenhouses, for heating or for cooling. So, yeah, we didn't have a great success in that regard because suddenly with a great change, the plants couldn't cope. But what we found was that they get to a point where they're very stable with certain fields, and then when the fields change dramatically, that's when they weren't coping. So what I reckon is we need to do is hang bottles around the plants, which we hadn't done, and maybe they needed more GanSs in the water because it just wasn't enough to cope with very extreme changes. What we also found was that as soon as they were really unhappy, it didn't take long and they all just died. It was like they were at the end of their season. So it looked like the same as when we were having frost and going into winter.
I think the point to remember here is, and we'll touch on soon in the next workshops, is that every season, every change in season is a different mangrove field. So the plants are exposed to a different environment. And so what we're thinking here is, even though we had some CO2 and plasma in the water, and it helped to cope during the winter and into spring very nicely, it probably just wasn't enough. We needed to up the amount of CO2 for it to really cope with the higher fields of summer. So we'll try next summertime and see how we can change that environment for them to cope during that extreme conditions for summer. And it's just a case of being able to change and increase that field around the plant so that it can cope with the higher strength of the environment.
So any question?
I'm just thinking, you mentioned that that you put balls of plasma around your tomato plants.
We haven't done that yet.
No, I understand. But in fact, I've got some very strong tomato plants. They certainly, the cocktail tomato stems weren't as thick as yours, but they're very prolific. But I've also got other types like Grosslisi and beefsteak. But the beefsteak is an enormous bush. And I'm thinking of putting some plasma balls around the area in the immediate vicinity. So I see if I can extend the life through to winter, because in previous years, was some years ago, I found that my tomatoes would go into winter, but perhaps they didn't have a strong enough plasma field to resist the elements. And so I'll be putting the ping pong balls with plasma in them around the tomatoes very soon. That's just a comment. No questions as such.
Mm. Are you taking photos there, Ross, so you can show?
I will start taking photos because I've got a very healthy crop of tomato plants and they're flowering now. Not sure what.
Yes.
But some of the fruit is coming, bearing on the plants. But
Ross, can you wiggle your mic or something? You sort of got a bit of interference on your mic.
I see. How's that?
Yeah, better.
Yeah, I've got a shield over my.
Yeah, it's still coming funny now again.
Oh yes, sorry. Well, that's about all I'm going to do. I will be taking some photographs, and I can put them on your program if you wish. Thank you.
Yes, send it to us. That'll be great.
Yeah, we like to have feedback. It's just, yeah, you know, people need to start sending us things, giving us things we can put up.
Good.
All right.
Anybody else?
Okay, so we'll have a look on the next one was how the plants coped with the heat of summer. This was our very, very first experiment in February of 2016. And here's just a photograph of our aquaponics system. Now, for those that don't know what aquaponics is, essentially we have a fish tank in the background there with fish. And we've got these 4 grow beds in front here. And then we have water circulating always 24 hours a day from one bed to the next. And then it circulates back to the fish tank and then through the water, through the beds again. So what is happening is the fish poo from the fish, that ammonia has been converted into nitrites and nitrates, and that's what the plants are using as their nitrogen source, is the nitrates from the fish. So it's a nice balanced system where the fish are feeding the plants and the plants are essentially cleaning the water for the fish. So we have no filters on the system at all. So let's just give you a background of how our system works. And with the water, we have just polystyrene rafts which float on the water, and just the little cups containing our seedlings are placed in those holes that you can see there. So this allows the plant to sit on top of the water while the roots are always in the water. And so we have that conversion of ammonia into nitrates for the plants. So that's just our source of nitrogen. Now, the background for this one was every summer that we've grown here since we started, we've always experienced extreme temperatures, and the water in our system can get to 26, 29, sometimes 30 degrees, which is very high. And this causes all sorts of damage to the root structure, turning them brown. The roots slowly disintegrate and die off, and this causes the leaves to be very thin with no real weight or substance. They're not very healthy. And our lettuce is stunted, and sometimes it'll just start bolting. So we always have that problem in December time, and it takes much longer for our seedlings to grow, 6 or 7 weeks, because they're really battling against the elements all the time. So in this one, we had placed a bottle of our GanS in the water. So we had a mixture of seawater GanS, CO2, and CH3 that we had placed in the water.
This was a very small amount of GanS. It was literally just one little bottle with a little bit of GanS at the bottom and filled with water.
We just placed that into the water there, so you can see it was just sitting and floating in the water. And the arrow on the right shows you the grow bed there, and the arrow with where the bottle was sitting. So this was planted 19th of February, and then you see on the picture on the right, 25 days later, we had lovely, stunning lettuce. And it was 25 days later, and then when we look at the root structure there, it was quite incredible how nicely that the roots had been maintained white, and really, really healthy looking root structure there for the plants. And what we had done, we had only placed this bottle into one of our systems, and we've got 5 systems there, and so they're all separate and independent. And what we found was we had only placed the bottle into one of them, and then we watched how the other 4 systems were battling. And these were photographs that we had took on one of the hot days. It was 30 degrees outside. You could see on the left, the lettuce were wilting and just not coping with the sun. And you see the photograph there on the right. This was the lettuce that was in the system with a plasma bottle, and they were just so upright, as if there was no effect from the heat at all. The next photograph, coming through, was just showing you the difference in the root structure. You can see there's system 1 and system 2, sort of browning of the roots. Not happily, if you actually go and pull on those roots, they would just pull off completely and disintegrate. Whereas the plasma system there, the roots were just so vibrant and really, really healthy looking. So that was a very noticeable effect. So our observations from this one was we had a very marked difference in the root structure of our lettuce grown with a plasma system. And we only saw this type of root structure during the cooler months of the year. So we're looking sort of from April till September time, never during our hot period. This was showing us that the plasma fields are allowing the plants to cope better with the higher water and air temperatures. So even though we were still sitting with close to 30 degrees in our water temperature there, the plants grew as if they were growing in water of 20 degrees. The high water temperature seemed to have no effect on them. The lettuce that were produced there was also much larger leaves. They were thicker and heavier, which resulted in a nice higher yield for us. And it also grew within the normal time. From the seedling stage was about 4 weeks instead of the 6 to 7 weeks during our hot periods. And then we saw during the midday sun there that our normal lettuce would wilt, whereas the plasma lettuce would be able to cope with those heat conditions. So our lettuce were exhibiting, for us, they were exhibiting traits that we'd only see in the growing seasons of spring and autumn when it was cooler. And in this one, we'd only used about 50 mils of GanS mixture in 24,000 liters of water. That's how much water one of our systems contain. So you can, and it was in a bottle, so we had never put any of the GanS directly into the water. So it was just the fields coming through the bottle and into the water, which gave us those results. From then until now, what we have done is we've been slowly adding more and more bottles of GanS into our water. I think in some of our systems now, we've probably got about 10 or 12 bottles in each one of our systems. So we've really, really ramped up the number of GanS that we've got into our system. We've also got CO2, CH3, and zinc in all the grow beds, and we're going to continue to add. And before I carry on, it's just a reminder that we sometimes do get stuck, focused that these GanSes are a fertilizer, but just remember that they are not a fertilizer. All they're doing is changing the environment for the plants.
And then the plant is feeding itself.
Yeah. So other observations between that first experiment and now is we've also been going through some very, very hot summer days with temperatures over 35 degrees Celsius. And we've seen the same thing. Our lettuces has not been affected by this heat at all. We've put the GanSes in all of our systems now, so we have nothing to compare against. But the results that we've seen over the summer month is quite incredible. We've constantly harvested healthy, very thick, heavy and vibrant lettuce throughout the summer period. And this is our first summer where the heat has not had any effect on our production or quality. We're still producing the same amount of lettuce week in, week out, irrespective of the weather, whether we're having bits of rain and cooler weather or whether we're having temperatures and a couple of heat waves of over 35 degrees. And we think it's because we've added all these additional bottles of GanS in our water. So we've really, really increased the environment, field environment around our lettuces. So there probably appears to be a threshold on the amount of GanS we need in relation to our volume of water that we're using, but also for your environment. You know, when we look back at our tomato plant, we only had, same thing, one bottle in the system. And so it would be interesting. We'll try again during our winter months when we've got a lot more bottles of GanS in our water, whether we'll have the same effect, or maybe the additional GanS will have really added and increased that field strength around our plants. So we certainly seem to see that by adding more, we're getting better results. Any questions on that one?
They're quite spectacular results, you know. We must thank Mr. Kesh for introducing GanS. It's
Yes.
an extraordinary result, you know. Most market gardeners should be very interested in your system.
Well, you know, we're growing in water, which is entirely different environment to people growing in the soil. But I think the soil, people growing in the soil will see the same effects. As long as you are really watering a lot of the plasma water into your gardens and create that strong field around the plants. We also know from our radish, when we grow in our radish, that they somehow need less water. So if people can just observe that when they've grown in the ground, that they might need to not have to water their plants as much, and they'll cope with the extreme heats without really needing a lot of water. Because I know Mr. Kesh has said that is one of the effects that one will see with your plants and using a CO2 is that you need less water for them. But yes, you know, our results for this December, January have been we're very happy with that. And it's just a case of adding more and more GanSs that we seem to be getting the better results. You know, we're not getting anything to the extreme where we're producing 10-foot lettuces yet. You know, that's still to come. And that's really looking at changing your environment and a stronger field around the lettuce. But for now, it's a case of producing good, healthy food in extreme conditions.
You know, when we go up the road to our friend who's the hydroponic farmer, on the day when it was 43 degrees Celsius, he's very busy hosing down all his lettuces because they're ready to just, you know, give up. Whereas we didn't even have to worry about going and worrying about our stuff because it was just fine. You know, and this is, you know, so many farmers, it's an uphill battle continuously, and you're always battling the elements. So this way, it just makes it so much easier to grow your own food. Even if you're growing in your backyard or if you are a commercial farmer, it just takes the scary part away a little bit. The only damage we've had with extreme heat at the moment is literally when we had 40-degree day, then we had 160 mils of rain, and then we had sort of 35 to 37 degrees. Some of the lettuces that had very tight cores and retained some of the rain sort of in between their leaves, the lettuces actually cooked slightly, which I don't think you can do anything about that unless we create our total Magrave greenhouse at this point. I'm quite happy with the results with those few lettuces that did have a problem.
It's a remarkable result, actually.
Yes, and I think, you know, as I said before, we'd like to get a lot more feedback from people growing in the ground, from their experience, because ours is different. And I think we'll probably get better results from growing in the ground because that is the more natural environment for plants, is to growing in the ground, not in water the way we're doing it.
You know, the ground actually has things in it like bacteria and fungi and all sorts of things that are helping and increasing the field strengths around the plant and doing all sorts of things that we can't do in our sort of unnatural environment. So I think people growing in the ground are going to get absolutely fabulous results from this.
Yes, I can test it out and see in some regards. Last season I had extraordinarily large oranges, which I put down to the fact that I sprayed CO2 GanS plasma all over the flowers and the leaves of the trees. But other than that, it's a season where we don't have oranges. We had no apricots because of the frost. Killed all the, although I sprayed plasma on the flowers of the apricots, the frosts were persistent and it killed all the flowers on most of the fruit trees. So even the ones that I didn't spray plasma on, so the whole lot went. So, but next season we'll see how things go, and I can give you some feedback. Thanks very much.
I think that's also maybe a test for the balls, because as we've seen with the latest teachings, there is this, and I think we need to start emphasizing it quite dramatically. To see results, you've got to breach a threshold. And so you need to add more and more plasma until you see the results, and you will get them. It's just maybe it's not strong enough until you get to a point where it is. Just like with the cancer cells that seem to need a threshold and then they all just disappear. So if we can create fields, and if they're not quite strong enough and you're not seeing anything, you need to add more tools or figure out how to add more fields. And remember, when you hang things with the plasma dilution, so if you've got 2, 3, 4 bottles, just make each one ever so slightly different, so you can create the gradient so that the fields can flow.
Yes. And
then also the rings. The rings might also do quite well with the trees.
I'm using balls at the moment, but rings will be. I'll put some out too. Thanks very much.
And the double rings seem to be much stronger than a single, a double tube seems to be stronger than a one tube.
Right, that's a CO2 outer and CH3 inner tube.
No, we use zinc on the inside. What I've found is, even with the balls, the gravitational needs to be inside and the magnetical needs to be outside. Otherwise, if they're reversed, they don't seem to push out the fields as much. So if you create a gravitational inner and a magnetical outer, you can actually combine zinc, GanS, a few of the oxides in the middle, and then add your CO2 and CH3 on the outside.
Oh, I see. Right. Thank you.
Hello, Lisa. Hello, Jimmy. This is Klaus from Austria. Hello.
Hello, Klaus.
Hi, Klaus. How are you?
Okay, very good. The last weeks I was busy, and the Zoom account has a little problems, but now I'm still online.
Yeah, good.
To the fields from the GanSes, we have the last weeks we had a workshop in Austria, and we played with different GanSes in bottles and put them on special acupuncture points from the earth. This ground force points I speak some weeks before, and then we have very much better results. The fields from the GanSes come out very natural, very strange, and when you put some bottle on a place, you have a spectrum from 5 to 10 meters, and when you point it, acupuncture point from the earth, you have fields of many 100 meters. And so we have to learn to look at these points, and I can give you advice. Maybe in 2 weeks we can make a little we can make a little work together.
Presentation, yeah.
Yeah.
Yes, fascinating.
And I told you I want to show my tomatoes that we harvest in October last year. Normally the season in Austria is for tomatoes from June to September, and look at the picture. We have this at end of October, and I give you.
Do you want to share there?
Yes, when I.
Okay, I'll stop sharing. Then you can.
Thank you. This was this type of Tatarinis. It's an Italian tomato, and normally they have a size from 3 to 4 centimeters. And I took this photo in end of November. And now I have a picture. This is from right now. Oh. Right. And now they dry. But all tomatoes are okay. And the other things are physalis. And physalis are normal when we harvest 2 or 3 weeks and then they are gone.
Those are the Cape gooseberry, are they?
Yes, we call them physalis. This is a cocktail tomato, a little orange thing, yes?
Yes, yeah.
From South America.
Similar family to the tomato, yeah. We've
Yes.
grown them in our aquaponics system, funnily enough, but they don't like too much water. So they grow, but they're not that happy. They prefer drier conditions.
Yes, but not one single tomato has gone. All tomatoes are right and only dried.
That's a similar thing we've noticed as well, is the fruit doesn't rot, as you say. It just slowly shrivels and dries, but it still remains healthy. Yeah, it's fascinating to see that as well.
Yes, and also the refrigerator, we see it with a pan for electromagnetic fields. The refrigerator had a magnetic field from ½ meter outside.
Was that from your magrav or just from the tomatoes?
No, from a very small magrav.
Mm.
Yes, and all the things we got in the refrigerator, they stand stable. Yes, we noticed.
Yeah.
Okay, that's from my side to the tomatoes. And last time I want to show you something about the work with water from the Victor Schauberger Vortex systems. And we built, you can see this?
We still see your tomatoes.
Oh, sorry. Okay, I have to share again. And this glass X built a very strong vortex system. You see this?
We just see your files.
Oh, sorry. Stop. Okay. Try again.
Yeah, that's better.
You can see?
Oh, no. Yeah, there we go.
Okay. And the water comes in, begins to turn. And in this vortex structure comes the water out, and this one very, very big size of the, what is the name?
Spiral.
Yeah, it's a very, very spiral, and it's
No.
a vortex structure. And when you give the water to the plants, the energy is enormous. And with this kind and a little GanS water inside, you have maximum effects.
Does this actually increase the effect of the GanS, the liquid plasma?
Yes, very strong.
I want some of those.
Yes,
I want to attach it to every one of our aquaponic systems. Then we can just add the extra fuel.
We built this also from ceramic.
Okay.
Stop. Here.
Oh, we got the files again.
Okay, sorry, stop. Now you can see another picture?
Yes.
Okay, and this is from ceramic. We built this for people in agriculture. One is right side turn and one is left side turn. With the left side turn, we can wash potatoes and other things. And with the right side turn, we bring the special water into the cell. And also the potatoes, big farmers, 200 or 300 hectares, every week they must bring out some potatoes. They are gone. 700 or 600 kilos every week. And after this work, they have only 20 to 30 kilos to sort out.
Can you explain that again, Klaus? I didn't quite understand.
Yes. One of the egg have a left turn.
Okay.
Yes. And with this left turn, we can wash some vegetables, different things, potatoes, corn. And with the right side turn, we bring this special water into the cell water from the vegetables. And then they still hold longer, very longer. And normal time, they took out every week some 100 kilos of potatoes. They are gone. And with this system, they have...
Because why?
Would they be rotting?
Yes, yes.
Okay.
Okay, so they were going bad. Okay.
Yeah. And with the right side, they have only every week 20 to 30 kilos to sort out. Very big difference.
Yes.
Have you put them onto the GanS yet? Maybe they'll have no kilos to sort out.
Maybe. Our period starts in March in Austria. Then we can show.
Yeah.
and this was different things, vortex structures from Victor Schauberger. And you know the kudu horn?
Yes.
The horn of antelope.
Oh, yes. Okay.
Yes, but this is also ceramic. We built this in ceramic, and this is the structure how every single element, every ion has his movement in this way, like this movement. Not the turn, like this spiral.
Like
also
spiral.
The Earth, also the Sun, this is the movement from all these elements.
Yes.
And when we bring the water in these systems, the water becomes its natural flow. And when we bring this natural flow in the cell water from the plant, we have a much more benefit. And this is what we this year to have to study and to search in the agriculture in conjunction with the GanS.
Yeah.
I think it'll make a stunning combination, quite honestly.
Yeah. Okay, that's from my side today.
Thanks, Klaus. I just want to question. I want to come back to the beginning when you spoke of the sort of energy points on the Earth.
Yes.
And how that increased the fields of the GanS. Do you have a method on how one can do it in our gardens?
Yes.
And that?
Yes, this is a resonance method from a teacher of me, is nearly a Nobel Prize winner. His name called Gernot Greve and Dr. Felsenreich. They also work in Australia with I've told, with the man of the tree. And we work with a basalt pendulum. And with this basalt pendulum, we can search these points and find this point.
Okay.
And we have 2 weeks ago, we have a workshop, and I show 25 people this method, and I think all can find these points after
Yes.
some hours, and we can make also a online workshop with you, and I send you maybe some basalt pendulums, and then we can work.
Yes, if you would like to put something together and then you can show us at the next workshop, I think it'll be
Yes.
great.
Okay. Well,
right.
This Sunday my mother had his birthday, and I have to break up in a half hour. But in 2 weeks, I have to bring these things in the front. Okay.
It will only be in 3 weeks' time, Klaus, because we do it the 2nd and 4th, and January there seems to be sort of 5 weeks where the Sunday comes into it. So we'll give you the date at the end of the show when that will come through.
Good. Okay. Yes.
That'll be lovely. It'll be very good. Thank you.
Then we have when we fix these points, then the spectrum of the GanSes and the GanS water is very great. We see this. We took a normal Markgraf system and showed the people the field from the Markgraf system, and then I stand this Markgraf on a special point where the best resonance for this type of Markgraf was, and the fields are going 3 or 4 times higher.
Yes.
Yeah.
Are these points close together, Klaus, or they're far away from each other?
These are 9 types of points. This step-by-step system, how the water bring in different energies. And
so even in a small garden, would you still be able to find something in a small garden space?
In every garden, you find all these points.
Okay.
Yeah, no problem.
That's good.
One question, please, Klaus.
Please? Yes.
Is there any difference in the northern to southern hemisphere with the flows and the acupressure points?
No. We find this also in Australia, or the North Pole or the South Pole is no problem. It's an energy system, a prime energy system from the Earth.
Thank you.
Yeah. Okay, thank you too.
Thank you, Klaus. So yes, if you will do one for our next workshop, that'll be marvelous. Thank you.
Okay.
Is somebody raising their hand? Because I see a raised hand, but I don't see it when I look. I see a raised hand here, and I don't know where it might come from. I'm going to viewers, I'm going to promote the viewers because maybe it's somebody on the viewers list. No, there's a couple on the viewers list here. So if I promote you and you want to ask a question, you'll be able to ask when you're promoted.
We filmed the last workshop and we have to translate it to English, but in this time the workshop is 50 gigabytes, so we have we make it shorter.
Yes.
And then we can give it in a Dropbox or something. But nice to be.
Yeah, that's a bit large.
Yeah. Okay.
All right.
Thank you.
Thank you, Klaus.
So did anybody else have a question? Okay, I've promoted the participants, so if anybody did want to, they can just talk.
All right. We'll come on to the last section there, and Lisa will do that. In terms of pest control that we found. Okay, so pest management, and
this is what everybody always wants to ask about, and how we can control pests. And we had this as an unintended side effect of our GanS administration. So another interesting effect we've seen in our is one of butterflies and moths, which normally cause devastation in our crops. We have to usually put a veggie net over all our crops, as you saw in the aquaponics pictures, because the butterflies and moths usually love to go and lay all their eggs, and then we get huge amounts of caterpillars, and they usually cause severe damage. They'll literally eat away whole rafts of lettuce when they all hatch out together. So because we are an aquaponics system and we can't spray any pesticides, in the past we've had to use different organic methods. Can you actually hear us? Because we're having something tell us we've got a problem. Are we still okay?
I can hear you.
Okay, so when the caterpillars do sometimes hatch, they can't survive. Now that we've got our GanSes going, we see very little damage when they begin to eat, and then they disappear or die. We think that because the lettuce leaves are so thick and healthy that the caterpillars can't eat the leaves. We've even had some crops in the open, and we've seen the same effect. A friend of ours who's growing bits and pieces in the ground has also experienced the same effect to the plants with his plants in the veggie garden. So what we've found is that because the plants are so healthy, they don't seem to attract the moths and the caterpillars, and they don't seem to be able to survive when they do lay a few eggs. Occasionally we'll find a full-grown caterpillar, but it's like one. And normally you'd find thousands of the things growing on your lettuce because they've managed to hatch. So this was a really good result on that. Our tomato plants, when our tomato plants were growing so well, we saw no pests at all. When the plants were affected by the extreme heat, you could see and sense that they were very unhappy. And very quickly we saw that within a week, all of the fruits had been stung by a fruit fly, whereas before not one tomato had been attacked by the fruit fly at all. This means that unhealthy plants give a different MAGRAV field compared to the healthy plants. And the plants, through their MAGRAV field, signal to the other creatures that they no longer wanted to live, and please come and share and take what I have. And the plants are giving back to the environment, so there's no loss. So a change in condition created the effect that the pests could thrive. So this is the summary that Jimmy can do on all the different things we've just discussed.
So by adding the GANs to the seeds and the plants, we are essentially changing the whole MAGRAV field around that plant. Not just affecting the plant itself, but the fields surrounding it. And results that we've seen so far is can extend the life of food grown with the plasma, which will have a huge impact on the whole food production cycle. Maybe not a good thing for farmers, because then maybe there'll be less waste of food, so less food purchased and grown. But I think in the long term, it's going to be great for consumers and for people to have food that actually lasts beyond 1 or 2 days in their fridge. The other thing that we've seen results on is growing in our winter, so we can extend seasons on either side of your typical growing seasons, or even maybe throughout the whole year. And once we begin to understand a bit more and really start creating certain specific environments around our plants, we don't see any reason why one cannot grow through the whole year, and even in desert conditions. And we've seen how our plants have grown through extreme heat. So what we've seen and shown today is just these sort of small changes are only just the beginning, and we think we've barely begun to see and use the full potential of what this plasma science can do for agriculture. And we think we'll look back in 2 years' time and we'll probably have 101 benefits for our plasma and see tremendous results. A couple of stories which we picked up. I'm just waiting for the screen to come through. It's a bit slow.
Oh, there we go.
Here we go. This was a farmer in Burundi, which was an interesting article that we'd seen on the golden age of GanS. He's a tomato farmer, and obviously when all the tomatoes are ready and all the farmers bring all their tomatoes to the market, they all get a very low price because of the huge volume coming onto the market. So he wanted to find a way to preserve his tomatoes so that when he took it to the market later, he would get a better price.
And also just stop them from rotting.
And stop a lot of his produce from rotting. So what he did was he placed his tomatoes in, as you can see there's a box full of ash from the fire. And this preserved his tomatoes for weeks. And so when I read this article, one has to try and understand now what is really going on here and why these tomatoes have lasted so long. And what we can come up with is your ash is all nanomaterials. And so what it's doing is it's almost forming by burying your tomatoes in the ash, it's almost putting a nano coating around your tomatoes and creating a sort of protection field around the tomatoes so that tomatoes are not interacting with your environment. And as long as they are healthy and good tomatoes, when you put them in the ash, they will stay healthy and strong.
It creates a balanced field inside, and then no outside environment can encroach. Just like the plasma field barrier Mr. Kesh always talks about in space, basically it's the same thing.
So that was quite an interesting article to try and, what one has to start doing is when you see these articles and things is to try and understand it and maybe explain it from a plasma point of view. And not so much from the old traditional science. We'd also received another couple of pictures from Gunay, and I'll just read you what she has said. I'm delighted with miraculous plant propagation. I'm very fond of the flowering tree crepe myrtle. I've been trying to propagate it from its seeds and twigs by striking, keeping the twigs or branches in water until they develop their roots. Until now, I've not been successful in any of them, and only 20 days ago, I took the pruning remains of a tree from our garden and put them in a water bottle with some of the CO2 GanS water and a hemoglobin water mixture. Today, I'm pleasantly surprised by seeing that they have not only gave out roots, but they've also developed buds and leaves. Normally, I could prolong the plants only in springtime, not in winter. So there she's showing the picture there, and thank you, Plasma Energy, and thank you, Mr. Kesh. And then I do have some more pictures that she sent through.
Taking long.
Internet's bad today. Taking a long time to come through. There we go. Right, so you can see there some pictures there of how her sticks just placed into the CO2 water are starting to shoot and look very, very healthy there. So there's another application of using the CO2 GanS. And you think with all those farmers that love to that propagate with roses and
no, not roses.
No, but grafting and doing all the graftings on trees and that sort of thing, they should also have tremendous results with using the CO2. So there we come to the end. If there's any questions or anybody wants to give some feedback from what they've experienced in having their gardens?
Just a question regarding Klaus's information. Will you make that available on this program? Apparently it's partially related to plasma science and partly to Victor Schellberg's experiments, which I've tried in the past. Would you make that available here, Jimmy?
Yes, we will. We will, Ross, because you know what we're looking at is a lot of the older technology, a lot of the suppressed technology, like that Schauberger and that, I think needs to come to the fore again, and it's using everything together in combinations. You know, and if this method enhances the strengths of CO2, then we need to use it.
You know, we'll probably figure out that it's the way the field interactions work, and you can probably explain it in a plasma way anyway. So I think, you know, as far as the plasma science goes, all of these things that work, and we're not quite sure why, will be explained by perfect field science. So yes, we need to add all of these things into our knowledge, because it's going to build a base that will really push forward, you know, the technologies of all types.
Yeah, just looking at it, you're correct. Yeah, just looking at it, vortex and spiral technology is in the magravity fields, and the trenches and things that Victor Schellberg experimented with have shapes that activate water, which definitely have an association with plasma fields. So I believe that that is definitely a link there to plasma technology and to Victor Schellberg's work. Thank you.
It's, you know, one has to look and realize that the water is a plasma itself. And so any method, the same as the homeopathy, where they will succuss the water and increasing the strength in that water, these are all sort of techniques and technologies that one can apply in conjunction with the plasma, using this plasma as well, because it's all dealing with water, which is the plasma.
Thank you.
Are there any other questions? As you'll see there, because of the sort of the way the calendar works for January, February, our next workshop will be 12th of February, and that is the second Sunday of February. So that's in 3 weeks' time, not 2 weeks' time.
I see Trish and Neil are there. Are they going to say hello today? Oh, we're not being talked to today.
Yeah, hello. Yes.
Hello, guys. How are you doing?
Yeah, we're doing very well. That's very interesting. All those things. One of the things that that we face here is that we've got, you know, farm water is you know, like farm irrigation from a muddy dam and so on. And I'm just thinking that, you know, things like this, like when their son was working in Mindubra picking oranges, they couldn't use the water out of the river. So the supply of water to all these agriculture things is pretty important. And I was just wondering if you're going to devote any time to, like I noticed that with your aquaponics system, you could drop a bottle into your system, which was very easy. But there must be other ways of changing your water supply.
Yeah, I think for now, what we sort of have seen in some of the teachings, they are putting some tubes around the water pipe. So they'd fill a plastic tube of CO2 and wrap that around a water irrigation pipe. And I know Renan has seen, one farmer there has seen some results by just doing that to his irrigation system.
Yeah, I'm wondering if we can't mix that in then with that egg, for example, because the idea is obviously, you know, when you're energizing your water with the GanSes, it does take a bit of time. So to me, it depends on how fast the flow is flowing through that field and to how quick it's being energized, and if we can add strength to it. So by using things like the little eggs that we saw, maybe that could actually give extra strength to the GanS energies.
You know, I think one can also look at anybody that's got some nice engineering background is to try and look at nice little fitting that one can put onto a hose pipe, so that from your tap you've connected to your hose pipe, and you know that the water coming out of your hose pipe has been energized, has got those fields, the CO2 fields in that water. So these are all little devices that one can eventually use one day or create.
I do know that Kesh Foundation is working on some form of water treatment, quite large water treatment. But yeah, that will have to have some engineering skill to create the devices and then understand how they work, and then they can be replicated.
Yes, we make different projects also with sewage plants, and we can see that the water, 2 or 3 weeks, the water is very stable. And we can show this on 12th of February, and we have some results to show.
Yes. Yeah, I think the technology in combination with something like that will where we can really increase the fields, will be a great benefit to everybody, particularly the farmers.
Yes.
Yeah, that's going to have huge applications. We look forward to hearing what you've got to say on that one, Klaus. Thanks.
Klaus, did you hear the question, or?
No,
Please repeat the question.
Okay, just a comment.
No, it wasn't a question, it was just a comment.
Oh, it's just a comment from Neil in terms of the implications, yeah. As I say, we're just touching the surface here. This is just the beginning for agriculture.
Yes, and water is the key. As I mentioned, water is in the plasma state. Water is the key to open the fields.
Yeah.
True.
Klaus, have you done any work with the plasma, just as a side here? If you take some CO2, for example, you must try a few little experiments to add some aromatherapy oils.
Yes, we spoke on Thursday with Mr. Cash, mentioned this. When we bring in this research project for GanS soaps, then we discussed this, and he say us, it's in this time they have studied the crude oil to mix it with different GanSes and bring it in a special state. And then it becomes nutrition for different sea plants and different sea animals. There is a work in the background.
Yes, I know, but what I did the other day is I took some CO2 and zinc, and I put it in a little glass vial, and I added a few drops of lavender essential oil. And when you hold this vial, you actually become lightheaded, like you've been for aromatherapy massage. So it has a very potent effect. And I was just wondering, in terms of different, different plants and their applications in terms of, benefits for other plants, for example, or human beings, and oils and things like this, whether the other GanSes like CO2 and zinc will potentize those kind of things very strongly.
Yes, we can see that essential oils, the name teaches, is this essential from the plant. When you mix it with GanSes, you can make this stronger. We see this by the soaps.
So just confirming, right?
Yeah.
Klaus,
It's all about.
Sorry.
Please.
Carry on, Ross.
Just one question. Has Klaus used frankincense in any of his soaps? Because that's a particularly strong oil, in fact. Frankincense. Sorry.
The key is the aminos. Mr. Cash told us when we have a fat on the surface of our hand and we wash it with the fat from the soap, in this moment they are building different shapes, different strings, and this is the function that works. The fat with the fat brings a new field. And also this can we make with mixture of essential oils and maybe different GanSes.
Thank you.
What he also said, which I found quite interesting, was that the smell actually touches your emotion and your soul. This is why it has such a strong reaction.
Yes.
So that's quite important. And as I say, even holding a little vial with lavender essential oil with the CO2 and zinc, you can get the effect almost of the oil without smelling it. It's quite strange.
Yes, but the oil, the smell from the oil come in a very old tale from the brain, and all the rememberings come out with a little smell from this oil, and also
yeah,
by the
because it's
plant.
touching your soul. Yeah.
Yes, also by the plant, you touch his soul. That's correct.
Okay, anybody got any other questions or feedback or hellos? All our other people sitting on the panel there? I won't put you on the spot and call you by name. Nope.
No. All right, thanks for attending. And so our next workshop will be on then the 12th of February. And then we also look forward to something from Klaus there as well on the energy points of the Earth. I think that'll be a great one to listen to. So thank you very much.
And it'll help us, because then we don't have as much preparation to do. So thanks, Klaus.
Thank you too. Can you send me your address, or can I give you my mail address?
Yes, do you want to send it to the, let me see, I don't think you can actually write on this.
I want to send to you two basalt pendulums.
When you pop out of the Zoom,
yeah.
Just look for me on the contacts, just type in my name. You should manage to find me.
Okay.
If you are you on the other teachings at all? So are you in the teaching group?
Yes. Okay. I can find you. Mm-hmm.
If you're in the teaching group, then you'll find me in the contacts list.
Okay. Thank you.
All right. Thanks for everybody for attending today, and we hope it was interesting. And we'll see you next time.
Thanks, everybody.
Thank you.
Thank you.
Thank you too. Bye bye.
Bye bye. Thank you.